everyone, and welcome to Efficient Water Planning with InfoWorks ICM. My name is Juliana, and I work in marketing here at MicroCat. And today's presenter is Tim, our applications specialist. At today's webinar, we'll discover how InfoWorks ICM's advanced modeling and simulation capabilities can help you optimize infrastructure, optimize decision making, and ensure sustainable water systems. As usual, throughout the webinar, you can ask a question at any given point on the left hand. You can ask Tim to revisit a step or ask any questions. And in the upper right-hand corner, you will find links to our social media, website, and YouTube channel. We post all of our webinars there at the end, so you can share with colleagues or rewatch it on your own time. And we will also be sending the on-demand recording of this webinar. So yeah, without further ado, I'll pass it on to Tim. Hi, Tim.
Okay. Hi, Huli. Thank you very much. Hello, everyone. I'm going to share my screen. There we go. And okay, you should be able to see my screen now. And
Yep.
I have a little PowerPoint that's going to keep me on track. What I wanted to talk about InfoWorks ICM. This is one of the products that came to Autodesk with the acquisition of a company called InnoVise out of Portland, Oregon, and they make water solution software. InfoWorks ICM meaning integrated catchment modeling. Okay, this is for river and flood analysis. You may remember that the Autodesk river and flood analysis software. Well, this will replace that and much more so. Now, catchment modeling or watershed modeling is done in a number of ways. There's a lot of different software that can do that. What's different with InfoWorks ICM is that word integrated, okay? That's because it can take sources from many different parts or different networks, put them together into a single solution, one model, okay? So I could have, for example, a storm drain network, and where its outflow point is, it goes into a creek, which I'm also modeling with InfoWorks ICM, and it can add the two together into one model, even though the one is a pipe network, one is just an overland flow network. But you can see this example here. I'm going to zoom in a bit on this. And you can see, for example, there's flow pipes. So these are drainage from probably up the street somewhere in the storm drain inlets. But for example, this area where there's a planter and there's plants in there. So there's filtration going on. And InfoWorks calculates all of that, adds it to the network. So it knows how fast, based on the material in the planter, it knows how fast water can come through, how much it'll be adding to the system. Okay. Let me zoom back out of here. This one just talks about how InfoWorks adds up all the water in this system. Doesn't matter the source. So it's going to model, for example, the planter, the storm drain inlets, the sidewalks and gutters and roads, rooftops, etc. It brings all that together into a single integrated model. That's what the picture on the left is supposed to be showing you. The one on the right, this is a photo of, I think it's in Oman or Qatar or one of those oil-rich countries in the desert that has huge flooding problems, and they call this the greatest water problem in the world as far as being able to calculate the storms and all that. and flooding in this area. Okay? And they use InfoWorks ICM for that. I'm not sure if you'll see, I have a video that I linked here, but it's talking about how you can integrate the multiple systems. And there are different types of systems. I'm not going to play the video because I don't think the sound will come through to you. But this is an example of a 2D mesh. So if I'm doing flood modeling, it uses the mesh to route the flood. Okay. I'm going to go down. These are the 4 different types of integrated models. So the 1D linked model, this is where I can connect, for example, the outflow from my storm drain network to a point on the river model or a model of a creek, etc. That's my 1D linked model. Then there's the 2D runoff model. This is for hydrology. Okay, so you can take that mesh, can be a surface model, which you can bring from Land XML. Excuse me. Let myself get distracted and lose my train of thought. I apologize. Okay. This can come from Land XML. Other GIS data. So if you have ArcView or ArcGIS software, you can bring surface models in from there, etc. Then there's the 1D, 2D linked model. So it's doing the 1D linked model with the, can be the pipe networks, can have the river flow, etc. But it also can use the flood modeling into a single linked model of both. Okay. And then there's the fully integrated catchment model. And this puts all your systems. So if I have a drainage ditch over here and I have a street that's going to capture a certain amount of water and its gutters and storm drains and the drain pipes, etc., it's going to add all that together into your fully integrated catchment model. I wanted to kind of go down some of the workflows that you would do when you're using the software. First, of course, you'd create or open your model database. And then you're going to import network data from various sources, which I'm showing you here. Okay. And you probably recognize a lot of these formats. For example, info drainage, that's our Autodesk drainage software, equivalent to like what used to be called storm and sanitary. Micro drainage, that's the old name of what is now info drainage. HEC-RAS, here's your SWIM 4 and 5 text files, more SWIM, and there's different ways of dealing with SWIM networks. Okay, so that's importing your data. Once you have it, you edit the network, which includes things like pruning the network. These pictures here are an example of that, where it can take these red links up in here and basically connect each of these nodes to one node down here, thus reducing the number of calculations that have to be done. The idea behind pruning is to remove some of the conveyances or the conduits within your network to reduce the amount of calculations that have to be done, but it takes into effect how that's going to affect the overall calculations. And so if it thinks it's going to, change it too much, it won't prune in that area. Okay. You can also merge links. So if you have links that are essentially the same thing. You know, they're both 12-inch cast iron with a certain amount of flow. Well, it can merge those into a single and thus reduce the size of the network. Now, dealing with small networks, that really doesn't matter. You know, if I'm the city of Tiny Town, California, well, pruning and merging aren't going to gain me much. But if I'm city of Los Angeles, I've got a lot of big networks out there, and these running the calculations takes time. Even with the fastest software there is, InfoWorks, for doing these calcs, it still takes time. And so being able to prune and merge is a big deal for productivity overall. Then you import event data, which is like your rainfall data, wastewater data. Here's an example of a rainfall intensity chart. Okay. And then once I bring all these data types in, then I need to validate the network. And it, like you can see on here, I'll zoom in for you in case you can't quite read it. This manhole, boom, ba-doo, boom, and possibly others, has chamber area below minimum in simulation parameters. So you get warnings of errors in your network, or misdesigns, if you want to call them that you'd go back and fix and rerun. Okay, here's an example. You run your simulations for your flood and your drainage, et cetera. Okay. This is just an example, the dialogue where you input the data, but you can see this is very detailed. Also, importantly, I think, is that your simulations can be scheduled. You know, if you've got a long simulation that's going to take a long time, well, you probably don't want to turn it on at 9 a.m. if it's going to take 3 hours because you want to continue working. Well, schedule it for 9 p.m. It'll run when you're snoring at home and come back and you're ready to go. Okay, so that to me is a big deal. This is just this is my last slide, and this is some samples of the different types of reports and charts that InfoWorks will create. Statistical reports and log reports. Time series reports, for example, here's flooding time in hours, does this sort of thing. Here's hydrograph report. There's my hydraulic grade line. Okay, the slope value for the pipes, etc. There's a couple other over here, probability type. Okay, this they're calling histogram. I don't remember seeing the R in histogram before, but who knows? Okay. So we have one question came in was, are you able to interact with Civil 3D pipe networks that you've laid out with Civil 3D? And that is a resounding yes. You see here in my ICM or InfoWorks ICM workflow, import network data from various sources. One of those sources is AutoCAD drawing file. So I've used Civil 3D to lay out a storm network, for example, with all my pipes and that sort of stuff. You can just read that directly in to InfoWorks ICM. It'll make a network in there, and you can do your calculations and simulations, etc. Okay, that is all I had to say today. So I will stop my sharing and turn it back to Huli.
Thank you, Tim, for that wonderful presentation. Um, I wanted to remind you all that if you want to learn any of these topics in detail, you can always take a custom training with Tim or someone else on our team. And I wanted to share our upcoming webinars real quick. So we have coming up next on August 8th, the role of AI in manufacturing software at 1 p.m. Eastern Time. We also have on August 15th an exciting one about Revit techniques, from parameters to schedules. And then on August 22nd, we'll have efficient civil 3D workflows, again with Tim, and best practices. So we highly recommend you to check our website for these webinars and register if you have any interest in any of this. And even if you cannot make it, we recommend you to register so you can get the on-demand recording for that. So yeah, if we don't have any more questions, I would like to thank Tim for this presentation and everyone for attending. We will be sending this recording, I believe it's tomorrow, and another follow-up email. So if you have any questions, just feel free to reply to those emails and we'll get you up and running with whatever you need. So yeah, if we're not missing anything, Tim, I would like to thank everyone.
Yeah. Thank you, Huli. Appreciate it. And attendees, thank you for attending. We'll talk
Thank,
again.
thank you so much. Goodbye.